Hi, everybody. This morning we're working on a mixed practice review for Chapter 4. The first task that they've given us is to draw and mark a diagram for each triangle. The first kind of triangle they ask us to draw and mark is scalene. That means that none of the sides can be congruent. So this side is going to get 1 tick mark, this one's going to get 2, and this one will get 3. That will indicate that all of the sides are different lengths, and so the triangle is scalene. Our next type of triangle is isosceles. Isosceles always reminds me of an ice cream cone, and the two sides of that cone have to be equal in length. And that would be your isosceles triangle. An equilateral triangle has to have all 3 sides congruent, and ideally those angles would be 60 degrees. We're going to go ahead and mark all 3 sides the same, which would indicate that this is a drawing of an equilateral triangle. Now, a right isosceles triangle has to have both a right angle and 2 congruent sides. Oh, maybe a little longer. There we go. So I'm going to mark that right angle, and I'm going to mark those 2 congruent sides. Voila, there is a right isosceles triangle. All right, number 5 asks us to complete the proof. Now, they gave us some information, so we are given that angle O is congruent to angle R, and that was a given. Then they said that OS is congruent to RS, and that was a given. Now, hang on, let's mark those on our picture, right? So I've got angle O congruent to angle R, so I have an angle. And then I have OS, that's this length right here, congruent to RS, that's this length right here, so I have a side. And then they told us, oh, look in the proof, they told us that angle NSO is congruent to angle ESR. All right, oh, and those are vertical angles. So NSO is right here, and it's congruent to ESR, which is right here. Oh, so I have another angle. Oh, look at that, it spells it. Triangle SON, so that's this triangle right here, is congruent to triangle SRE by angle, side angle. And so, of course, because those 2 triangles are congruent, then their parts, SN and SE, can be congruent by CPCTC, or corresponding parts of congruent triangles are congruent. Problem number 6 says that PC, this tower right here, is a vertical radio tower on level land supported in part by the guy wires PA and PB. What additional information is needed to prove that the guy wires are the same length by? So they would like you to prove that these 2 guy wires are the same length by CPCTC, but before you can do that, you have to prove the triangles to be congruent. So there's a triangle here and a triangle here. Now, the first piece of information that they gave us is that PC is a vertical radio tower on level land. Now, if it's vertical and the land is level, then it's created a right angle here and a right angle here, right? So we have one angle, and we know that this side is congruent to itself on these 2 triangles. So if we wanted to prove that the 2 triangles were congruent by side, angle, side, then the next side that we would need is we would need to know that side AC is congruent to side CB. Okay, so that would prove that those 2 triangles were congruent. If we wanted to prove by angle, angle, side, since we already have an angle and a side, we would just need the next angle over. So we would need to know that angle A is congruent to angle B. Next, by angle, side, angle, we would actually have to know about angle P, but it's kind of confusing because there are 2 angles up here. So let's be real careful about how we're naming this one. So we would need to know that this angle here is congruent to this angle here. So let's start with angle APC. Oh, that's the P, is congruent to angle BPC. And that's it. If you knew by any of these methods that the triangles were congruent, then by CPCTC, you would know that the guy wire PA was congruent to the guy wire PB. That guy wire, again, is like the metal wire that's sort of tied to the ground to support that radio and keep it in place. Okay, number 7 says using the graph below, plot the points for the two triangles, then complete the following statement. BAC is congruent to, and then another triangle. Okay, so remember your congruent statement always has to go in order. So let's start with just BA. When I look at BA over here, I'll notice that the length is, I'm not sure exactly what the length is, but I know that I go up 2 squares and 1 square to the right. On this other triangle, the length that's analogous to that one is this one that goes 2 by 1 again. So I'm going to say it's got to be E to F. And then the next part, A to C, is the longest side of that triangle. And so the longest side of this triangle from F has got to be from F to D. All right, so if I followed that triangle around, I started with B and went to A and then to C, then I would be writing the same congruency statement by following this from E to F to D. All right, let's look at number 8. Mark the given diagram to show each shortcut method. So side, side, side. If these triangles were congruent, we would have to have this marked as a side. You would need to have one of these sides marked and one of these sides marked. So side, side, side. For side angle side, they have to have an angle that's congruent. Now, because we have vertical angles here, we already know that this angle is congruent. And so the sides on either one of those could be congruent. Side, angle, side. Angle, side, angle. Well, the side that's shared already is this one, so that's a freebie. So to get angle, side, angle, I would need to know this pair of angles and this pair of angles. Angle, side, angle. All right, next, angle, angle, side. So this is a little confusing because the triangles are orientated differently, but we would need to have a side that's the same on each one of them. So I'm going to go ahead and mark those two, and I'm going to put the S on one of them. And then we'd have to have an angle that's next to it. So there's an angle and a side, and then of course we'd need that next angle. So angle, angle, side. Angle, angle, side. Just because they're oriented differently doesn't mean that they don't have to have the same parts. All right, so for hypotenuse leg, you have to have a right angle because there's not a hypotenuse if you don't have that right angle. You would also need to have the hypotenuse be congruent on both triangles, and you would have to have one leg congruent on each triangle. Okay, so hypotenuse leg. Lastly, they're asking in number 13 for us to find the indicated measures. Okay, so let's look at this a little bit. I want to start with angle 2 here because I have a linear pair between 63 and angle 2. So to find angle 2, I would take 180 and subtract 63. So borrow a little bit. And 711. So angle 2 is 117. And then this angle here would also be 117 because those are vertical, right? So those two angles are vertical. I think that's going to help us with angle 3 in a minute. Now to find angle 1, if I know that all of the angles in the triangle are 180 degrees, I would add up the two angles that I know. So 48 plus 117. 165. And then to find angle 1, I would take 180 and subtract 165. Borrow a little bit. 15 degrees for angle 1. All right, now angle 3, sort of the same deal. I know two of the angles in this triangle. I just have to find that third angle. So I'm going to add up the two angles that I know. 134. And then I'm going to subtract that number from 180. Borrow a little bit. Oh, I'm sorry, 6 and 4. So angle 3 is actually 46 degrees. Okay, have a good day and good luck on that quiz.